All right, good morning, everybody. Welcome to our weekly core protocol sync. Today, we're going to be doing a deeper dive into the changes to the protocol itself. Nazar, if you'd like to go first and let us know high level what you've been working on.
All right, so this is the monorepo side. It looks like there are exactly 20 pull requests that were merged last week or about last week. So one of them was building a Arch64 platform. We will have images for containers and we will have executables for Arch64. They are not optimized because optimization takes even more time and we are hitting the 6-hour limit of the CI, but we have at least something, which is a good start. After that, there was voting pull request. I think I went through it last time. It was merged 6 days ago, but I think it was submitted before that. So unless you have questions, we can skip that. Then there was a small breaking change for the farmer CLI. As we are testing it as developers quite frequently, I was lacking this TMP parameter from the substrate where you start it every time with a temporary directory and you don't have to like wipe it manually every time. So that was helpful. I think I went through this as well with the base directory change, right? It was probably also last week. Then there was minor update to the Gemini documentation. Feel free to interrupt me anytime if you have any questions. The primary changes are the chain spec name that is different. Unsafe pruning is not a thing anymore in upstream substrate after upgrade. And what else? Yeah, that's basically it. I believe there was a pull request where archiving flag is specified here as well because it's no longer the default, but I think it's a different pull request. General improvements. Yeah, I was trying to see if we can do something to speed up our builds. One of the things I noticed that switching from runtime debug to debug counterintuitively, for some reason, makes the build of the runtime smaller in size, which usually means it's also faster. So I did that, and also I removed some generics in some crates. Nothing major in this pull request. This is some small refactoring. Yeah, this is update to the pull request that Luchain did. Right. Then there was a problem. There was a minor typo here. Let me see. Yeah, so there was a minor problem with the voting mechanism. The way it worked, there was a verification done in the pre-digest, pre-dispatch. Did anyone has a question? I think Oscar was unmuted. So there is basically two places where we call the verification for the votes. One is from pre-digest when we are trying to build a block, and another one from the transaction pool. And if we return an error from the pre-digest verification, the storage changes will be rejected or like ignored. And if you return the OK, then it will not be. And that was a problem because we were checking the vote, and if it was invalid, we were returning an error, which means you can basically spam the network with invalid votes, especially in case of equivocation, without any punishment. And we did want to persist the equivocation result. So what we did instead, the function which does verification. Oh, that's a different request. Okay, let me go with that explanation for a different pull request, I think. Yeah, this one. That was a different problem. So here, what we did instead in the function, which is the check for the vote, we are returning an error only in case there is anything wrong except equivocation. in here. And if there is an equivocation, we are actually returning OK here. However, since we did equivocate and the changes to the storage were persisted, we actually can check it later separately. Or more specifically, we are actually returning error from here, but in the pre-dispatch for the vote, we are actually considering that to be OK, but we do call equivocation handler. So when we go into the actual transaction, we can check if our public key of the solution was equivocated to because it was in the block list. Otherwise, it wouldn't get there. Then we can actually return an error. So the transaction will fail, but we still kind of letting it through the pre-dispatch in this case. And if it's like some other error, then it will be rejected in here because there are no storage changes. So that was one problem with voting. The other one, the parent. Basically, we have time slots, and those time slots correspond to like the history in time, and then we have block heights, which are not one-to-one mapping because it's probabilistic process to create blocks. And there was incorrect check as to what the parent block's time slot is. And if it turns out that you've created a vote, at about the same time, someone built a block instead of vote, and then there is yet another block on top, and you want to include basically a little bit outdated vote, it wasn't included because it didn't have a proper check for the time slot. It was rejected because of that. So I had to fix the parent slot field of the current verification data for the vote. And then I also had to write a few test cases that verify that specific edge case to make sure all of the votes are included. This is something we've discovered on the pre-Gemini testnet with our team, where some of the votes were rejected incorrectly, and the frequency of rewards was not as high as we expected. So that was a small bug. And this was just a minor simplification. It was unnecessary to do all of this matching. We can just put data into it. Okay. Yes, this was slightly updated later, the pull request, but basically we were using snapshot dash and the date for the snapshots as a convention. We will start using a different convention. We will use Gemini 1A and then 1B and then 2 and so on for the snapshots, such that they are kind of more distinguishable between each other. They're not just dates anymore. So this basically changed our pipeline code to reflect that. Okay, this one. What we wanted is we wanted to not to like protect the network from all kinds of things that can happen on the non-incentivized or not or incentivized testnet. Primarily because we don't have all of the features implemented. For instance, we do not enable cost of storage. And that means that you can basically for free, essentially, submit a lot of data to the network. And we do not want that. So what we've implemented is a mechanism to prevent basically any kind of transaction to be sent to the chain unless storage access is enabled or the author of the transaction is sudo, so like root user. This basically prevents all kinds of transactions because all kinds of transactions, they actually have some kind of storage associated with them, and this will reject them on the transaction pool level. So if you submit a transaction to transfer balance, to store object, to do whatever, it will actually fail. The only transactions that are allowed are something that is unsigned and is not the pallet executor. So you can submit the vote, for instance, and that will be fine. So there is a fuse in the pallet subspace, which allows you to turn it on, but it's off by default in the chain spec. In here, it's false. Does it make sense? This is, by the way, a signed extension for the transaction kind of thing. In Substrate, we weren't using it actively before, but we do now. Then we had this just random value for the fees from every like percentage of storage fees that were going into the escrow, and then the percentage that is taken out of that. It was half of the fee was going into the escrow, and then 1% was taken out. Now it's just 10% that goes into the escrow, and then 1/100th of a percent goes into back into the user from the escrow on every block. But we do not expect this to be anything significant because we do not have anything, any transaction to actually use that. So basically, like Genesis, like seeding of the history that is done by the root user is the only source of the escrow. It will dry out very quickly. And since it was like one Shannon per byte, it's just nothing. We have like 18 decimal places in the coin. So it doesn't really matter, but it's something more reasonable, closer to real world, but will be tweaked later as well. Yeah, this is something we've discussed. Basically, we were using non-canonical signatures. We should have used canonical. That required a lot of changes throughout the code base. That's why pull request is so big, but I think we've discussed it in quite enough detail to go into that too much here. Yeah, the palette executor was kind of disabled, but not really, in a sense that we were using this mechanism for the call filtering. The way it works, it actually works on a later stage. So the transaction will get into the block. It will occupy the space in the block, but then it will be rejected by the runtime during execution. What we want instead, we want to not include it in the chain at all. And for that to happen, we've added another signed extension that instead of verifying the regular transactions, just like we did here in the check for the storage access, instead we were actually verifying the unsigned extrinsics, so we can again reject them before they go into transaction pool, and we care about rejecting the executor transaction specifically here. So none of them can be submitted because we do not have proper verification for that yet. So there is no point of receiving ERs or fraud proofs here. So again, relatively simple check. Another thing is the ParityDB and RocksDB. RocksDB is used by default in the node by default right now, but it will change to ParityDB, and actually data structures in Substrate, if you are not using CLI, already default to ParityDB. This pull request basically makes it a little bit future-proof, where it forces to use ParityDB all the time, and that allows us to disable RocksDB entirely. I have a pull request in Substrate that I'm working through with upstream to physically disable RocksDB support on our node, so we don't break anyone once we do that. No one should be using RocksDB by that time, and that allows us to actually improve the time of the builds, because when we are building the node separately as an image, we don't have to build RocksDB, which is a bunch of C++. And that should allow us to decrease, again, times for the AR64 builds, and generally improve CI times by not building unnecessary stuff. And ParityDB is using a little bit less memory, but I also think there are still some issues in Substrate that consume too much memory, but this is a step towards that. And there is there is an issue about removing RocksDB completely, and from there we can actually go into the where is it? In here, this is a Substrate pull request about removing ability to disable RocksDB physically on the feature level of crates. Okay, any questions about that? Okay, on a similar topic, I noticed that during farmer builds this time, SP core takes just unreasonable amount of time to build. It's like so huge. There's so much stuff in it, and again, it's impacting AR64 builds in particular. So I just replaced the usage of that crate, which was Substrate specific, with just upstream crates that basically the logic that we used from that crate is implemented with. So there is a new function here implemented, which is to parse SS58 reward address from CLI into the public key. That's all we care about. You don't care about anything else in the crate. So we had to add a few direct dependencies, but the build is like 1 hour less for ER64. And of course, for the regular build of the farm, it's also much less. And we don't need to pull all of this repository, which takes like 15 minutes in case of the farmer. So good upgrade all around, I think. There are some fixes for GitHub Actions. I changed the protocol ID from Gemini 1 to Gemini 1A because we'll have multiple generations and we didn't want to have conflicts because of that. Small documentation about strongly suggesting to open this port so we can actually have peer-to-peer network instead of star topology with our servers in the center. And we will extend this port range with more ports once we have DSN. Because that's how people will connect to each other. Yeah, hope it makes sense.
I have a question about that. So right now, starting from Gemini, the nodes will be peer-to-peer connected and retrieve data from each other. Like why do we need this now? Why did we not need it before?
This is a more future-looking, so to speak. It was working before primarily because we had a lot of people running it on servers.
Mm-hmm.
Once we have a lot of people running it on desktop, you'll notice that most of those people are actually unreachable. So we are connecting through the servers. And what we want to have a situation where more people can connect to each other directly.
Okay.
Then there was a minor refactoring for the runtime. We basically had this libjs, librs, which was really long, and I moved a few things related to feed processor, fees for transactions, object mapping, and signed extensions into separate modules to make this a little bit less. No logic changes whatsoever here. Then I was trying also to experiment with building of Substrate node with Rust standard library compiled at the same time, such that we can do link time optimization throughout the whole thing. That should improve performance and reduce overhead. And there is this build STD feature, which is unstable in Rust. However, in order for that feature to work, there is a currently restriction. You need to specify target. And if you do specify target, even if it's the same target as your host machine, it creates a subfolder under target with the name of that target. And then it creates like debug and release and everything inside of that. And our WASM tools, again, wasn't ready for that. So I did an upgrade which handles that. It takes one component out of the path after target and checks if it's equal to the target. And if it is, then it's a target, it's not a profile. So we need to push that into the path, and then we can use profile after that and compose the whole path to the WASM blob. So that fixes that. It doesn't really impact anything except it handles one merge case. But I think in the future it will be helpful to improve performance. Just something I wanted to check. And if we are doing at some point cross-compiling of the ER64 builds or any other builds for Mac or for Linux, it might also be helpful because it would have failed because of this. Yeah. And the final pull request is
Do you have a
basically.
question, Shamil?
Yeah, but yes, I have, but for different PR. I will keep it for when he finished.
Okay. This is a simple one. Basically, when we merged all of the changes for the runtime and we've built the final chain spec, I've added it to the source code and enabled it in the node and added our bootstrap nodes. And this is what our incentivized testnet looks like. And that's all of the changes in this repository. And I think it's enough for now.
My question was about our build time for that architecture. Is it a pressing issue for us? Because there are ways to optimize it.
It wasn't that pressing issue. It was like nice to have. And when I had time, I just experimented with it a little bit. It wasn't critical, but some of the people were trying to run it on ER64 already. If you go to our Subspace testnet and we go to the statistics, there are actually some people that have built it from source. So I was just thinking that we can make it life a little bit easier for them.
When it becomes pressing issue, just contact me. I have 2 ideas about it, how to just improve the speed of the compilation.
Okay. It's like the primary challenge is that we are building RH64 on this. So it's like all emulation. That's why it takes so much slower, but I will contact you.
We could just pre-cache all the build artifacts, and on the next build on the changed code.
Sure.
And it will definitely increase 5 times the speed of the building.
The challenge is that we are only building RH64 like once a month. And the code at that point is completely different, and the release of Rust is probably different, so there is not much cache reuse,
Okay.
unfortunately.
Okay, great point, Shamil. I'll let you guys take that offline for later. Nizar, I did have one question about the memory consumption that we're seeing.
Yeah.
You said there's an upstream substrate issue with that. Could you just describe that quickly?
Sure. So I've submitted an issue a while ago that RocksDB uses more memory than ParityDB. It's in upstream. Yeah, it's here. I described it. It's actually, I think, is not correct. ParityDB does use less memory, but not like 2.5 against 17. It's actually kind of strange because I was checking one server and it was like 1.8 gigabytes, and the other server, which is running the same code base, sync the same way, the same operating system, everything is the same. It uses like 8 point something gigabytes, and my machine uses like 17. So I'm not sure what's going on. There is a correlation between the amount of RAM you have on your machine and the amount of RAM that the application uses. So if you have less RAM, it will use less. But even on the same kind of machine with 16 gigabytes of RAM, one machine took 1.8 and the other one took 8 gigabytes. Doesn't make any sense to me. However, there is one related issue upstream, which is this one. I have a red notification for that. That says that there are some problems with transaction pool, which is something we were using during sync process, but not during like initial seeding of the history, but not during the sync process. So I'm not sure if it's too much applicable, but they were able to reproduce it, and they're working on some kind of solution, I believe. So I will follow that for what is happening. Yeah, I'm not sure how big of a problem that will be. We'll probably have to try to run it on the 4 gigabyte VM and see if it runs out of memory. It shouldn't, I think. But if it does, then we'll need to look closer into it. Telemetry so far shows that we do not have many machines with that little RAM. Most of the people have way more RAM than that, than 4 gigabytes. But this is something to keep in mind for sure.
Okay. And I think it's going to be more of an issue as we get more people using the desktop app, because it seems to be more like the team and people that are running the node on their home computer versus people on the servers that it's obvious, that it's consuming all their RAM.
Yeah. Either way, it shouldn't consume like 17 gigabytes like in my case. It just doesn't make any sense if the plot itself is like 6 gigabytes or something. We'll look into it. I don't have a specific answer yet.
Okay. Any other questions for Nizar from his update? Okay. So let's shift gears and talk about Shamil and Ivan, what you guys have been doing on the networking and the plotting side. I guess maybe Nizar, would it be helpful for you to sort of give an overview for the team of kind of how you're dividing up the work between Shamil and Ivan and kind of what the short-term roadmap is for the DSN?
So the short-term goal for us is to make farmers sync from other farmers. Right now, what's happening is as the node is syncing itself, it will submit all of those archive pieces to the farmer so farmer can plot them. However, we want to decouple that, and we want to make node lighter, and we want to make node decoupled from the farmer. And for that, we need to have a network, like a separate network where a farmer can talk to another farmer and pull pieces from them. For that, we need to first have that network, and then we need to be able to discover farmers which have similar plots to ours, so we can pull some of the pieces from one farmer, some of the pieces from the other farmer, and then we can write those pieces to disk. And in that context, Ivan is working on the part from the farmer side, that talks to some kind of API of the networking and requests pieces and plots them. And Shamil works on the other side, on the networking, that establishes connections, builds the network, sends those requests, receives requests, transforms them into some kind of stream of pieces and that kind of thing. So they are working on the same goal, but they are working on from two sides, and they have some kind of shared API in between that they agree on that they can use.
Okay, great, thank you. Let's see, Shamil, would you like to go first?
Okay, so last week I started to work on the get pieces by range method for the DSN. I spent some time on research of possible implementations, including Bitswap protocol, and design a method workflow variant. As I simplified it, during our call, initially I planned to add 2 different protocols optimized for different use cases. I encounter an issue of our current approach. libp2p demands lookup keys to be hashed, which contradicts our use case of the middle of the range. I created some dirty hack with unsafe Rust to bypass it for now, but this code snippet should be reviewed with attention or probably deleted in favor of upstream libp2p code changes. Currently, I started migrating the request response protocol code from the parities code base. And my plan for this week to adopt this protocol, request response code, for our libp2p stack. And if this task takes only a couple of days without any issues, I will start assembling all protocol parts for a draft PR. That's it. Questions?
Questions, why do you need to hash it? Because the queries for pieces where piece IDs are already hashed was already in there.
Yes,
it didn't require like extra hashing.
Exactly, we don't need that, but libp2p implementation does that without any workaround. They use internal structures that accept these bytes and then hash it, forced to hash it. We don't have a choice on this issue. So I needed to construct some kind of key that was not hashed. So I just use memory transmute API from the Rust to artificially construct or to access private fields.
Oh, okay.
It seems to work, but it needs to be tested and reviewed, of course. But probably the best implementation is to create a PR for libp2p code base with explanation why do we need the direct non-hashed key for our system. It's not my first priority. I want to just get it to some workable version first.
Okay, can you create a thread in the engineering and send maybe a link to the branch where you have it and describe a problem so I can also take a look at that?
Okay, problem.
Thank you.
These are for pieces themselves, right? Not for objects?
Yep, for specifically for their indices.
Okay, well, could we not just address them internally by indices, and then when we pass them to libp2p, they'll get hashed, and we can just not pre-hash them?
Yes, and that's what I'm trying to achieve, because
we cannot, because we are not requesting them by numeric value. We are requesting them by the range when they are hashed already. So it's not like we're requesting PC index from 1 to 10. We are like requesting random ones, which are, after hashing, are actually sequential.
Okay, so this is not for like get piece by index. This is for get piece by range.
This is for sync,
okay.
Yes.
Right,
Yep.
never mind. Okay, that makes sense. Okay, thank you, Shamil. Any questions from the group?
I have one, but not to Shamil actually. What is the progress on Windows slow syncing?
Windows what?
Slow syncing of Windows for now.
It's fixed. Like in the in case you use native runtime, it's already fixed. It is also fixed upstream without that, but it's not part of the Substrate version that we are using.
Okay,
It will be on the next upgrade.
Okay.
All right, Ivan, can you go next, please?
Yeah, sure. Let me share screen. Here it is. So during last week, I created a pull request adding a snorkel keys to the Rust P2P. So we created a pull request for that. Also, we forked Rust P2P in order to like discussion on snorkel keys go forward, and are still using them for our own use cases. So we need those actually for the for the networking, as we use those kind of keys for the plots. Yeah. So there's nothing fancy interesting here. But yeah, I also integrated that and added networking for each individual plot. So beforehand we had only one networking instance for the whole farmer, but right now we have that for each of the plots. Yeah. So that right now all of the plots can request like the pieces from the other from the other plots on the network. Yeah. Yeah, and we integrate that and use that. Yep. Apart from that, there was a minor thing. There was a minor pull request related to the adding changing some Rust MT options. And the last one was adding the farmer DSN mock for syncing and adding the sync algorithm. So it's kind of done. We're just discussing the API with the Nazar here. Yep. Right now it looks generally like this. Yeah. We have the trait, which is called DSN sync. And it only has one method. You can just get pieces from that. Pieces are located in some range, which is also supplied in the arguments, and you just get the stream out of it. The stream, you can just pull it, and from time to time you will get like the pieces to plot. Which this is just a structure which is which contains like pieces and the indices. Yeah, and there's one simple marker for us right now, which just disables the thing. And this thing, it always like returns empty stream. Yeah, and with that in mind, we just have a sync algorithm which just requests pieces until some callback says that we need to break from the sync. We already synced and everything's fine. Yeah, and for that there are like some of the tests. Yeah, I just wrapped the B-tree map, which would let us to take pieces which indices are like in our range. Yeah, and for that, yeah, there's just some simple tests for that, and algorithms seem to work for that use case. Yeah, I guess that's it from my side. As for this week, I hope to finalize that, and looking forward to some new issues, I guess, from the DSN side. Do you have any questions?
Thank you, Ivan. Are there any updates, or is there anything that we're still working on in the background right now around the benchmarking of the plotting or the optimization of the plotting itself?
No, nothing like that. I also helped Ozgan a bit with debugging the desktop farmer, and I also faced some of the issues related to that. I mean, on our like farmnet, like yeah, I failed to farm like a block within 3 days, I believe, on a single plot. Yeah, and that was kind of suspicious, but yeah, also if we calculate like the um, um, the probability of actually getting the block, it's supposed to be that I hit the 30% probability of not getting a block or something. So it's kind of like weird, but still, yeah. Apart from that, nothing, yeah, which I did previous week.
Okay, thanks for the update. Ivan, any questions from the group? Okay, Özgen, any updates on your side? And if not, can you just let us know kind of what the progress is of getting desktop app synced up with all the other changes that were previously described?
Yeah, I don't have any updates on core protocol side. And for the second question, the dependencies are updated. The node and farmer code is updated. I'm gonna need a re-exportation of something from Nazar related to Node. He already knew about it, so it's fine. And I will add boot nodes, and then we will do the update related to Schnorr keys, and then we will be good to go. So I already tested everything in local setting, and Node and Farmer was able to produce log. I'm talking about Gemini, so it should be fine. Oh, by the way, Ivan also tried it in local setting. He was also able to produce a blog. So I assume he previously was not able to farm a block was related to maybe his own setting or maybe due to some old code, but I think it should be resolved now.
All right, thank you, Özgen. Any questions? All right, Lu Chen, you're up next.
Thank you. Page on my screen. Okay, so last week I firstly working on the client-side fraud-proof verification, which is basically to verify the fraud proof in the transaction pool. But the current behavior of validating the transaction is by using a runtime API. This validates transaction in the transaction pool to validate the submitted transaction, which will have to call it into the runtime, which is not something we want. So we basically want some hook, which will run before this runtime API call. So I made this discussion in the Subspace repo. And yeah, I received some feedback. So the one alternative is to make a wrapper about the existing transaction pool. Yeah, that is something I'm currently working on. And I have basically made this wrapper compile while I was starting to add this pre-validation to the existing runtime API validation. So I found that the current test framework for the series is kind of broken, and the architecture is outdated. Since the previous major refactoring on the decoupled execution. Initially, it's the primary node has an optional component, which is the embedded primary node. But after the major refactoring, it's the opposite. The primary node has an optional component, which is the secondary node. So, but we haven't upgraded the test framework. We only update the production code. So I later was working on this test framework upgrade. So there is basically no logical changes to the production code. Is basically all for the test. There are some small minor refactoring to the.
Hey, Lu Chen, sorry to interrupt. I just want to make sure I understood that. So before you would run a secondary node like an executor, which might include a embedded primary node, and now you run a farming or a consent, not necessarily a farmer, but a primary node, a consensus node, or a full node of the main chain, and then you can optionally run an executor on top of that. That's the way it's set up now.
Actually, technically, you still run like 2 nodes, 2 full nodes to complete the substrate nodes, but it's just like conceptually, like which is in the primary position. Like previously, before the major refactoring about the decoupled execution, which is made by Nazar, we like firstly run a substrate node, which will be considered as the secondary node, and then we start a second node, which will be considered as the primary node. So that is the executor. It has 2 substrate nodes, like, but now we still have 2 substrate nodes, but we firstly starts the primary node, and then we start the like secondary node, like kind of that.
Right. That makes sense, because you really can't run a secondary node without there being a primary node. So it should be a dependency. Secondary node should be a dependency of the primary node.
Yeah. We basically swap the dependency between the secondary and the primary node. Yeah.
Okay, thank you.
But
for
the
going
test,
over that.
but the test framework wasn't upgraded. So I have to update this because there's some issue like during like this like mismatch, like the slow notification is somehow is disabled when you like start the executor. So I made this, and also like the side effect is like I also fixed a flaky test during like creating this VR. So that's everything happened during last week, I think. Any questions?
And what will you be working on this week, Luce?
Oh yeah, I'll continue like working out this alternative like approach, like moving the fraud proof to the like client completely. It's almost half done, but yeah, I have to maybe in a few days to organize. I'm currently working on a separate branch. Yeah. After that, if you know you already have the proper design written for the multiple sector runtime, I might start working on that after this.
Okay, great. And in terms of Gemini, what do we need to do, or sort of what are the next steps around enabling decoupled execution in its current form, so that we could actually run an executor on the network?
I think this client-side fraud-proof verification is the most important one. After this, we can try to like launch the executor.
Okay, great. Yeah, so that would be the next step, would be to after we get that client-side fraud-proof verification done and we're able to test it locally, then to be able to deploy an executor onto Gemini in coordination with Nazar embed, and hopefully that will work. If not, there will be some debugging, some additional debugging, and then we can unlock the fraud proofs verification or submission, I guess, through an upgrade.
Sure. Yeah.
Awesome. All right. Any questions for Luce? All right. Thank you, Luce. Ved, you're up next.
Hey everyone. Not anything major on the protocol side for me. Mostly focused on infrastructure last week, bringing up the Gemini 1 infrastructure up. This week, apart from supporting with Nazar, last week I had a call with Jeremiah as to where I'll be focusing next, at least on what we've discussed was to actually focus a bit more on the partition validation, a bit more higher up, actually having a light client for Subspace. So I'm trying to get some kind of an idea about light clients that are there currently being done that are more decentralized, trustless. Just getting some idea, putting some notes, and Jeremiah as well shared some notes with me, mostly going through them along with supporting Nazar however I can on the infrastructure side.
Great, thank you, Ved. Yeah, and just continue to make that your priority. I imagine there's going to be some hiccups this week. We just need to be prepared to handle any of those as they arise regarding Gemini. And then in your free time, continue to work on the research of those materials. And when you're ready to sync up, feel free just to go ahead and let me know, and you can grab a meeting on my calendar.
Yeah, cool.
Great. All right. Any questions for Ved from the group? All right. Daria, do you have anything you'd like to add?
I was mostly when you were guys talking, I was also trying to figure out with that stuff about Schnorr signatures and things. Will try to wrap my head around all of that stuff and see if what were the assumptions that were made with for the library that you were using, and why that was not making canonical signatures, and if there is a way to trigger them to be canonical instead of using VRF for that. So I'll look at that this week as well.
Okay, great. Yeah. If you would like, we can once you get wrap your head around that, then we can set up probably a quick call with you and Nazar and I to review those findings. And if you can try to explain to us kind of in simple math how that actually works, we would love to understand, because we're kind of playing with fire here a little bit. I think. Go ahead.
Yeah, the only issue I have is that I'm not that good with Rust yet. So if someone could point me to the actual where the crate lives that you're importing, I would appreciate.
Just ask Nazar. Just
Okay.
ping him on Discord in the public channel, and he can point you in the right direction there.
Yeah, I was
in that
about.
thread.
Okay.
Yeah.
Well.
And I believe so. From what I understand, the way the library is designed, if you just use this like the sign function or the sign method, it's not going to be, it's going to be malleable. That's just the way it's supposed to work. But if you use this VRF sign method with this special context, then it will be this canonical signature. But there's something around the way this context is constructed, which is just not really clear. There's like an example of the way Babe does it that we're reusing, but it's just we're not really understanding why it's done that way.
Yeah, so the first thing I would like to look at the actual code of that library and see if there is a way to make them be canonical. Because the way, I implemented, I was exporting it from OpenSSL in my previous workplace. There was a way to ask for them to be either deterministic or random. So there may be that the RISC library has one too. So I would like to first look at that. That is the case.
Okay, that makes sense. There's actually the Web3 Foundation. They have a website where they have some of these specifications defined, and they have a Babe spec in there. There's a paper for Babe. Okay, so I'm just going to share this link with you right now in the Discord. This paper will probably describe at least the protocol, which should map to the VRF. There's a whole bunch of notation in here around the VRF and the signing. So this might even be a better place to start, just to understand the abstract protocol.
Okay.
Ved, did you have something you wanted to add? No? Okay, just saw you unmuted yourself. Okay, great. All right. Any questions from the group? Anything else we need to discuss before we close out? All right. Well, thank you everybody for watching, and we will be seeing you guys next week with more updates. Bye-bye.